Okay, so before we get into the thick and thin of all this fun stuff, real quick, I always like to mention, I have a Facebook page for, it's basically a developer blog at this point, so if you ever want to see the stuff I'm working on, you can check it out. Second off, we've got a pretty coupon code for you guys. I want to try something new on the site, so if you guys want to save a little cash moolah from now until February 22nd, 2019, we are going to have a 7% off store-wide code. So yeah, if you want to get some goodies, anything on the store, 7% off. The coupon code JeepLove. So go check it out. Happy Valentine's Day and all that stuff. A little love from me to you. Yeah, buddy. On top of that, just a quick reminder for anyone that's got REMs and things like that, especially if you got older ones. If you have any of the originals, any of them REMs or the REM Plus, these friggin' dinosaurs, for the love of God, please go to my website and update, if you haven't, the latest software update. The last one that I posted, I think it's like 0.86 or something like that. Please update to the latest software. It is a huge, massive, insane improvement over anything you've ever ran. It will make your device feel like new. It'll be faster. It'll be smoother. There won't be glitches. Please update your old devices. And just in general, if you have, always occasionally check around and see what the software updates are looking like. Be up to date. I promise you it will make your experience so much nicer with these devices. And, yeah. Besides that, on top of that, if you ever have custom requests and things like that, or you need help or things or anything, please reach out to me, talk to me, speak to me. I promise you won't be a nuisance. I love to hear feedback. I don't hear feedback very often, so please let me know how the devices are doing. Let me know of problems, of bugs, of glitches, little silly things that are just slightly annoying. Let me know. I won't know if you don't tell me, and I will fix them. I promise you. I will do my darndest to fix any little problem or glitch or thing. So if it's even remotely annoying, please let me know so I can fix it. I want my products to be beautiful and perfect and not annoying. So, yeah, I'd love some feedback. Thanks. Anyway, I think it's on to what this video is really about. It is cold outside. My Jeep's making noise. And I don't really feel like going outside, so what better thing to do than work on a project? Isn't that right? So, here's a hint. What might we be doing with some arcade joystick goodness? What plans could I possibly have in store for us today? Well, maybe we should find out. Okay, so here we are inside the heap, and check it out. So this is kind of what you could do with it. So you could put a shifter somewhere that has 4 gears, so you could choose your first, second, third, and fourth, as long as you could figure out how to mount the thing. But I think that could be really cool for a manual setup. Now this particular unit is kind of bulky, quite large. So, if you wanted to cut into the center console and remove the e-brake, or if you have an e-brake off to the side, you could drop that in there so that could drop down. And if you cut through, you might be able to get it flush mount, so that could be really cool. Okay, so if you did something to relocate the e-brake or put it somewhere, that's about how high it sits. And it's also a little off-camera kilter. If the wiring wasn't underneath it, it would sit even lower. So it's close. So if you were to cut out the bottom and make a custom cover plate, I think that would look really cool. Especially if you wanted to notch it out on the side so it's farther to the right or something, or the left or whatever you're interested in. That could be really cool. So, yeah, there's an idea for you. And if you can figure out any other kind of ideas, if you find a smaller shift or something you could make, you could do switches or something. Hell, if you wanted, you could do a push button. If you just wanted 4 different push buttons, do first, second, third, fourth, or if you wanted like an upshift, downshift kind of thing, if it was momentary, downshift, upshift kind of thing, you could do a two thing, or a 4, really whatever you could figure out. So yeah, that's a thing. Like this guy over here, that's what this does. That locks the second solenoid so I can keep it in second or third. So that's really useful for me, is if I'm throwing it into first, I don't want it to like always drop into first. So what I'll do sometimes is, well, we'll be in drive, put it in second, and then throw it here so it's absolutely in second, and then when I want first, okay, we're in first. I want second again, okay, we're in second. It's still, you know, the TCU kind of controls the shifting sort of kind of, but you can definitely go, no matter what, this is going to be second. And hopefully that'll be first if your RPMs are low enough. So yeah, there's all kinds of different ways you can do this. But for you guys that are looking for some kind of way to turn joystick inputs into gear shifty business, I think this will be what you're looking for. As with a lot of the projects that I work on, a lot of them are customer requests. That's how some of the things that I've made have come to life, like these little TCU Buddy scanner projects. It was customer requested, and we finally turned it into a product. So, I think it's time to move on to the next level. I got a request for making a AW-4 shifter. So the basics is that we're going to take some kind of joystick or other input device that can select gears, and we want it to make the transmission shift into the gear that we want. But, you know, we can't do anything simple around these parts. So, this is going to be a full-blown, crazy frackin' controller. So, you know, over the last week I've been trying to put this together, and I think she's just about done. Everything's looking pretty good. I'm just working on interfacing it with the transmission computer. But this is our work in progress for the AW-4 Shift-O-Matic controller. Again, the name might be different, I don't know. It's just the nicest thing I can think of for now. I like Automagic, but a lot of companies seem to use that name, so that kind of sucks. But yeah, Shift-O-Matic or like a Manumatic is kind of cool, but that's like a generalized automotive term. You know, and an ASC, that's a decent three-letter acronym. Doesn't seem to show up too much on the Googler. But yeah, this schematic is looking pretty good. So we got our jacks, we've got some inputs, we've got controls, and so forth. So the way that this Johnski is going to work is we're obviously going to have a shifter. Okay, and the one that the customer selected is actually a arcade shifter. If you've ever, you know, been to a movie theater or anything like that, you've probably seen these before. These are the Cruisin' 4-speed shifters. So basically it's got an H gate on the bottom, and we have 1 through 4 that we can shift into. So the weird thing with these is it is biased towards one side. So if you try to leave this in the neutral position, it'll flick over to one side. It's always the same side. So it doesn't stay centered. But it will stay in whatever gear you put it in. So this is cool, but it's a little bulky, and they're a little costly. On eBay, you're lucky to find them under $50. Generally, they're going for about $75, maybe more. And that's not including shipping. So yeah, look for a spin anywhere from $75 to $100 to get one. You can get them new for about $100 online as well. But I don't know if they come with the wiring. So, you know, we got the actual mechanical part here, which is like a joystick on like this pivoty boy. And underneath you can see this little H pattern, which actually holds it. You can see all the limit switches in there, the micro switches that do the flippity doodahs. But if we look on this, see that little yellow dot when we go over? It's got a metal thing, and I'll push it in. So that's what actually is doing the electrical work. And we've got wires over here, and wires over here, that terminate in a nice little harness. I was able to find out that these are standard 0.100 inch header. So we can easily interface that. I don't even have to cut the wires. And the way they're ganged up is, as you would expect, every switch has a positive input or whatever you want to call it, a sense line, and then they're all ganged to ground. So it's real easy. So for this particular one, we need 5 pins, 4 for the switches and 1 for the ground return. And yeah, that kind of adds up after a while. You know, it's a lot of wires. So on top of a shifter, you know, we need a way to interface it to the transmission computer. One of these guys right here. This is the brains of the operation that actually, you know, controls your transmission. So what we need to do is take control over this. We don't want this guy shifting while we're shifting, so we have to basically cut the line from here so that this guy can do the work instead. But it's going to be smart. We're going to have some kind of switch or something that you can easily flip between auto mode and manual mode on the fly. So if you're on the trail and you want to, you know, throw it into gear, even when you're cruising around town, you want some manual control, flip it to manual mode, and the joystick will now do what you tell it to. In between gear shifts, it will remember what gear you're in, so if it ever falls out of place or if something weird happens or in between shifts, it will always be in the last gear that it was placed in. So if it was in first and then it's sitting in neutral, it'll still stay in first no matter what, and then if you want to flop it into third, it's in third now. So yeah, this is going to be pretty smart. I'm going to try and, you know, add as much logic and creativity into it as possible. So on top of gears 1 through 4, we are also going to have an input for the torque converter. So if you would like to lock that up so that you can get slightly better engine braking or, you know, things of that nature, try to get better fuel economy on the highway, things like that, we'll have an input for manual torque converter lockup as well. Or if you want to try to assign it to a gear or some kind of logic like that, we can do that. For this customer, he said when it's in 4th gear, he wants the torque converter to be locked up. So okay, we can do that. So yeah, we've got control over all 3 transmission solenoids. We can easily switch between auto and manual. And the nice thing is this device, if it's not powered up, it will always be in automatic mode. Like the TCU will take control. It won't know the difference. Everything will be hunky-dory. So only when this device is on and you flip the auto manual switch to manual mode, then it will take control. On top of this, we have sense lines for all 3 solenoids. And we're going to have a screen that interfaces this guy. So it's going to be rather simple, nothing too crazy. But it's I2C, so we can kind of use whatever the heck we want. So currently this is the screen that we're thinking about using. It is basically a tricolor. It's dual color, but you can get 3 colors out of it: red, green, and yellow. So this is just going to show the gear that it's in. And it'll be, I guess, green for auto mode and red for manual mode, so you can tell the difference. So this can tell you what gear you're in no matter what mode you're in, which is interesting. I'm also thinking of adding like a very basic menu along with diagnostics, so we can have like one of these light up for every input or output. Like say you want to see if the solenoids are on versus what the input is and things. Well, yeah, like a debug mode. And also, I want to use the shifter as the menu selector, so if you have to change like some very basic options, we could do that. So my idea is like, we'll throw it into, it's going to have to be in auto mode, so this menu will never appear when you're in manual mode shifting, but when you're in auto and the transmission computer is doing its thing, we'll take this guy and we'll shift it like, you know, forward, backward, forward, backward, forward, backward, or something that you would never do on your own. And then after like the 3rd time, it'll enter some kind of menu mode. So then you can go through your options and you can select things. And we'll figure out what options are needed when we start coding. That'll be next week. But yeah, that's just an idea for now, is that we can do that. On top of having like a 1 through 4 manual, like completely locked system, I can also do sequential. So if you guys just want to toggle switch up, down, you know, just downshift, upshift, we can do that. So that way you could sequentially go through all the gears and you'd have a lot less to work with. You could work with just a simple toggle switch. Just, all right, manual mode, we want to go down a gear, okay. Go down a gear, okay. Up a gear, okay. Things like that. So yeah, sequential is a thing. I'm going to make it so that you can custom map whatever you want. This is going to be an open-ended project. So if you have a shifter idea of your own, you have some kind of input, you got 5 wires that you can, you know, turn into things and stuff, please do. That is going to be the idea with this. So if we come in here, we've got a couple connectors over here, our 8-pin Ethernet. That is going to be for all of our switches. So we've got gears 1 through 4. We have our auto manual switch. We have our torque converter switch, and we also have an input over here for, it's an analog read pin, so it can read voltages. The point for this, the customer wanted the screen to auto dim with the dash. So most of my projects use light sensors, so it'll just see how bright it is and go, okay, we'll dim it or turn it down. But he wants it to work with the dash and variable dim as well. So like if you were to turn the dial down more, the screen will get dimmer with the lights and, you know, so forth. So we got a little 12 volt sense line that he can hook up to his dash lights, and, you know, we can dim based off voltage. So that's a thing. This smaller guy over here, this is going to be for the screen. We've got our two I2C lines. We've got 5 volt ground, and we also have a line over here that we could still use for a light sensor. It's a ground reference, and the light sensor would have a 5 volt pull up, which you can do and things like that. If, you know, we've got options, and we still got an extra line over there that we haven't used yet. So that's an idea. So those are the two main inputs. Is you have your joystick input, you have your screen output, and it's going to be a little screen you can put wherever you want. You know, it's hooked to a telephone cable, and it'll be thin and small, and you can put it wherever the heck you need. So that is that. This is going to be based kind of off like the Trinity fan controller setup. This is an AT-Mega, whatever the frig, 32U4. It's got the built-in USB, all that, so we can update it, put on code, all that good fun stuff. And for some really bonus nachos, this also has a data reader line on it. So for Renix guys, OBD1 guys, we can read in the data line, and we can do really smart logic. So we can do safety modes or nanny modes or whatever the heck you want to call it. So say you're cruising, you know, you want to do a little bit of, you know, fast driving, highway driving, and for some reason, oh no, you're doing 60 and you went into first gear. Well, what happens now? Who goes poof? Well, with the data signal, we could read it and go, hey, we're going too fast to drop into this gear, and we could either tell it to ignore the input or just drop down as low as safely possible. You know, we're talking like red line, like if the engine's going to spin faster than 5,000, ignore the gear until you slow down. So that's an idea. Another one is torque converter based logic. So if you hit the brake, unlock the torque converter. If you're going less than 5 miles an hour, unlock the torque converter so you don't stall. Things like that. So these are fancy things we can do with data. OBD2 guys, I can't do anything with you guys yet because it's entirely different. It's beyond the scope of this project. It's not simple. It's not easy to add into. Speaking with OBD2 guys, you have a lot of computers, a lot of annoying things, and you have that glorious check engine light. The problem with a lot of these shifter projects, like the stuff from like Rad Design and things like that with the manual Baja shifters, by the way, he's a really cool dude. We were chatting on Facebook, and oh my god, he's awesome. So I'm really glad that I'm getting input from guys all over the field about this project. A lot of support. I super appreciate that. That's really cool. But what he mentioned is that these shifter projects will they upset the computers and set a check engine light. A lot of people don't like that. On top of that, from what I understand, when that check engine light goes on, it will ignore the solenoid or not use it or go into like a limp mode. So it makes it even worse when you go into auto mode. You have to turn the key off and turn it on to get your transmission back, your automatic shifting stuff. So that would be annoying. So right now we have a level 1 solution. I'm using relays to take control because it's easier that way. There's almost zero resistance. There's no power required to do any fancy things. It's real simple, real basic, real cheap. So the relays will take control, and when they flip over, we have load resistors. So that way, when this shifter takes control, the TCU is now going to be on a dummy load, so that way it doesn't register a fault. Oh no, the solenoids are missing, there's an open, there's a short or whatever, because that's the main problem. The second it realizes that it's not connected to anything, it'll throw a code. So this is going to be our 95% solution here. This will fix 95% of our issues for OBD2. And it might even for the younger, like the previous generations, they do throw codes, but they just kind of work as normal. But yeah, the biggest problem is OBD2, I think 98 plus or something like that. They switched to different speed sensors. So they have an input speed sensor and an output speed sensor, and they also up the resolution from like 4 clicks per revolution to like 16. And with that added timing, they can calculate transmission slippage. So they will actually tell when the transmission is slipping more than it should between the input and output. I mean, there's going to be some because the torque converter and things and stuff. But if it detects too much slippage, it'll also set a code for the transmission not working properly, and also put it into limp mode. This, from what I've seen on forum posts and things like that, is usually in gears 2 and 3. So when you're going between 2 and 3, from what I've heard, it's people that are, really giving her the beans, driving on the street or whatever, and they're flipping like crazy between 2 and 3, and all of a sudden, hey, the transmission realizes that something's not right, I'm not in the gear I want to be in, and oh look, now we've got a slip code and problems. This is going to be a really difficult solution. So the idea would be to have a fake input speed sensor output to trick the transmission computer into thinking everything's okay. This would require probably having either a really smart helper or having a vehicle, like a vehicle at my place to actually work on and test. This is not going to be an easy, quick solution. This would be some kind of pulse counter that we would have to modify the signal and timing and then send it back out to the transmission computer so that it knows, that it thinks it knows it's going as fast as it wants to go. So this is like, that would be like a level 2, like super duper trickery. So we're not doing that yet. I'm only doing that if it really seems like it is necessary and it's kind of simple to pull off. That's the things that we can do with smart stuff like this. We have logic and we have speed at our disposal. So yeah, we'll get there when we get there if we need to. But that's the basics, the down lows, and the in-betweens so far. It'll be a bring your own shifter kit that will do everything you need for your AW-4. Any kind of manual modes. And we're talking like any kind of logic is possible here. We can have things like this with all gears. We can have sequential. You can have basic inputs. Say you just want like a lockout. Like say you want like, I just want first gear or I just want second gear. You can just have a simple push button and something like that. I mean, this might be a little overkill, but you have possibilities. You can do things. You can basically do whatever you want. That's the wonderful thing with Arduino and code, and I'm keeping the code open source, so any super nerds out there, you can make this do whatever the heck you want. So that's the lowdown on that. So the board is basically done, so I'm going to just make sure everything's okay before I do that. The biggest issue now is just interfacing it with the transmission computer. So as you can see here, the Renix and OBD look like this, and they got this 32-pin connector. And you got something like this on the harness side, and that'll plug in there, and you're good to go. You would have to be cutting some wires. You'd have to cut all 3 solenoid wires. You need a power input. You need a ground input. And if you want to do data smart things, you got to do data. So that's a lot of cutting into factory harness, and I know people don't like that. I don't really like that either. But it was a little hard to track down these connectors. So digging through Mouser and, data sheets and stuff, I did find some things that are fairly close. The biggest problem is that these alignment marks at the bottom do not match these guys. So if you see at the bottom that we got like a middle one and one kind of off to the side, and this one is, it's off. It doesn't line up. Doesn't line up with this one. Our gray one is different too. So that one goes that way, and the other one goes the other way, so like the alignment marks are different. So the easiest solution would be you can just shave them down, just take a razor blade or like something, and you can easily cut them down to size, and then they'll slide in. So I found ones that are close, but they're not perfect. So this is easy. I can put that on the board. I will have to cut notches. So in case you don't want to mess up your factory connector, if you want to keep the nubs, I would have to cut some, personal slots in there so that it will interface properly. So that's a thing. This is easy because I can just solder it straight to the circuit board and that's good to go. This one is a bit more difficult because it requires wiring. We need to put in all the wires. We need to crimp all the connectors. We need to assemble it. We need to get all these pieces and slide them together. I did actually track them all down, and they are fairly cheap. But I don't like labor-intensive stuff like that. So if we come over here, we have the female adapter, which they don't have a picture on this one, but this looks like it is the closest one for what we need. We have these secondary lock clips. We got this lock clip and that lock clip. So that's what, $1? It's like for, you know, a little over, it's like what, $2.50, $3. We have the connector we need. Then we have to buy all the pins, and I have to get wiring, and I have to wire them together. So if you guys wanted a plug-and-play wire solution like this, that's probably going to be looking at another $25 to $30 on the order because I'll have to build them. And that's obnoxious. You can make your own if you want. That's completely fine. I'll share the numbers and you can do whatever you want, because that's not something I really want to do. Crimping and connecting and all that is it's time consuming. Especially if this takes off. I don't want to have to make 50 of these. That takes time. But yeah, that's the lowdown on the connectors. So we could do that for a nice easy plug and play. That way you're not messing anything up. If that doesn't matter, if you're fine with cutting things, then we'll just supply one of these guys. We'll have all your inputs, all your outputs, and you just screw them into place. Real simple, real easy, real cheap. And you're on your way. So that is basically the last part of the puzzle that I'm just trying to figure out is that. So once we get connectors figured out, then I'll probably send an order out for like maybe 10 of these, test them, see how they work, see what's good, bad, and otherwise. And yeah, we'll go from there. So that right there is the AW-4 shifter project. Like I said, if you guys want custom things like that, very occasionally I do like to take on custom things, especially if it's going to be popular with people, because what you like is probably what other people like. So yeah, we'll have relays and data and load sensing and smart things and all kinds of crap. So yeah, that's that so far. So I guess let me know what you think, and if I didn't mention something, please let me know what might be of interest. Like I said, it's I2C, which is a very, very popular thing. So we could do things like LCDs, we could do OLEDs, all kinds of crap like that. So like this is I2C, these big monochrome graphic displays. We have smaller ones too, laying around somewhere. But yeah, there's all kinds of options for things like that. So yeah. Okay. Well, I think that's that project in a nutshell. So that's what I've been busy working on and doing lately. It's been keeping me busy, and it looks like a lot of fun. The other really big thing is just finding a shifter. So if this doesn't work out, it's a little big, it's a little bulky, and it's a little expensive. So, you know, if I can source them online new and they're okay and good and people are okay with paying that price, well then hey, it is a solution. But I don't know if it's the best solution. So if we can find something smaller or thinner or just something that fits well, I mean, if you want to be that guy, you could use like the Baja shifter that way too. You could connect the Baja shifter to my shifter to have, you know, smarter stuff if you really needed. You know, it depends on what you need or what you want, but that is also a possibility. So, yeah. But anyway, let me know what you think. This is starting to run a little long. I've got a lot of other things going on with the Nick and Time design stuff, but I just wanted to share that for now.